Welcome to the 6.4 video, which is Proving Triangles Similar by AA. Today we're going to start learning the different theorems that can be used to prove triangles are similar. Today we're going to learn AA. Tomorrow in section 5 we're going to learn 2 other theorems. So, just as a reminder, similar triangles have sides that are proportional and angles that are congruent. So it's like taking a figure and blowing it up or shrinking it to get a similar figure. So the first theorem that we're going to learn today is AA similarity. 2 triangles are similar if 2 angles of one triangle are congruent to 2 angles of another triangle. So drawing ourselves an example, these 2 triangles are similar if I have one pair of angles congruent and a second pair of angles congruent. Here I have one A and then I have another pair of A's. So 2 pairs of angles congruent means that I have 2 similar triangles. So let's look at some of the following examples. First example, are the following triangles similar? Explain. Write a similarity statement if they are similar. Well, the first thing that we're going to notice is that BE is parallel to CD. That's what these arrows mean, parallel. If I treat AC as a transversal, then this angle is going to be congruent to this angle. So ABE is going to be congruent to ACD because they are corresponding angles. They're both to the right of the transversal and above their corresponding lines. By that same idea, these angles are also going to be congruent. So now, my little triangle here is going to be similar to the bigger triangle. So we're going to say triangle ABE is going to be similar to triangle ACD by AA similarity. And you need to make sure you include this tilde here, so I know that we're proving similarity and not congruency. Okay, let's look at the next one. Again, we have parallel lines. In a situation like this, I told you to look for the Z. So I have this Z here, which means that angle L is congruent to angle P. I have this Z here, which means that angle M is congruent to angle O. And then furthermore, I have vertical angles. So not only do I have 2 pairs of angles congruent, I have all 3 pairs of angles congruent. So these triangles are definitely similar. The top triangle is triangle LMN. Now I need to match up angles. Angle L is congruent to angle P. Angle M is congruent to angle O. And angle N is congruent to angle N. And then we would say by AA similarity. Okay, we're going to do one more together, and then you're going to do one on your own. So looking at this example, at the second row, the one to the left, we have triangle CDEF. So I have this right angle, and I have another right angle here. Now looking at the triangle on the left, I'm going to look for that missing angle. So I have 32 add 90 add x equals 180. So this becomes 122 add x equals 180. If I subtract 122, I get x equals 58. So this angle up here is 58 degrees. Just for fun, let's find this angle here also. I'm going to call that y. So I have y add 58 add 90 equals 180. So this becomes y add 148 equals 180. So I get y equals 32. At this point, you should see that the left triangle is similar to the right triangle. So I have 32 and 32, 58 and 58, and I have the 90-degree angles. So these triangles are similar by AA. The left triangle is triangle CFD. Now I need to match up angles. Angle C is 32 degrees. That matches up with D in the right triangle. And then F is the 90-degree angle. So F is the 90-degree angle on the right triangle as well. triangle on the right, that is. And then D, in my left triangle, 58 degrees, goes with E. So this is by A similarity. So again, you have to match up the congruent angles. Right now, pause the video and try this next example on your own, please. Okay, looking at this example, first thing that you should have done is find the missing angles. So I have 26, add 90, add x equals 180. This is x. I get x to be 64. Triangle on the right. I have 64, add 90, add y equals 180. This is y. I get y to be 26. Okay, I should notice I have 3 pairs of congruent angles. I only need 2 pairs, but I have 3, so I have a little more information. So the triangles are similar. I'm going to say triangle CDE is similar to, okay, C is 26 degrees. That matches up with K, which is 26 degrees. D is 90, which matches up with G, which is 90. E, which is 64, matches up with H. And then we're going to say by a similarity. Okay, you might have a different similarity statement. So you might have DEC and GHK, or EDC and HGK. You could have a different ordering, but you have to make sure that you have the correct corresponding angles. So hopefully that went well. If not, we have a few more chances to redeem ourselves. Okay. Take a minute, pause the video, and try these next 2 on your own, please. Okay, let's see how we did. So I have 52 is congruent to 52. And at first it appears like that's the only information I have. Well, I also need to remember that the small triangle and the big triangle both contain angle A. Doesn't matter what angle A is, but they both have angle A. So angle A is going to be congruent to itself. So my triangles are similar by AA. The little triangle is AEB. A is congruent to A. E goes with D. And then B goes with C. So that one was tricky. Hopefully we got yes, the triangles are similar. Okay, then the third one. All the angles in the first triangle are congruent. All the angles in the second triangle are congruent. But do I have any angles that are congruent to each other between the 2 triangles? Well, if all the angles are congruent, that means that the triangle is equiangular. If the triangle is equiangular, that means all the angles are 60, 60, 60. And then I have 60, 60, 60. So I certainly have 2 pairs of congruent angles. I actually have 3 pairs. So we're going to say they are similar by a similarity. So that one was tricky. Initially it looks like no, but yes, the triangles do end up being similar. Okay, let's move on. Okay, so now we're looking at an example where these lines are not parallel. So it says BE and CD are not parallel. So I'm going to cross that out. Could the triangles still be similar? So is it possible that they would still have 2 pairs of angles that are congruent and still be similar? I'm going to leave this one up to you. We will go over it tomorrow. You must have something written down that shows me that you put thought into this question. So come back to it. Let's go to example 5. A flagpole casts a shadow that is 50 feet long. At the same time, a woman standing nearby, who is 5 feet 4 inches tall, casts a shadow that is 40 feet long. How tall is the flagpole to the nearest foot? Okay, so here we have our flagpole, as you can see. It casts a shadow 50 feet long. So hopefully we all remember that a shadow goes on the ground. And let's assume that the flagpole is perpendicular to the ground. Okay, at the same time, a woman standing nearby. So then I have this little woman right here. She's 5 feet 4 inches. So 5 feet 4 inches tall. She casts a shadow that is 40 feet long. How tall is the flagpole to the nearest foot? So this is what I'm looking for. Okay, I have two similar triangles. And I have two pairs of sides on the first triangle, and then I have two pairs of sides on the second triangle. Okay, so we are comparing the height of the object to its shadow. So the woman is 5 feet 4 inches tall, and her shadow is 40 feet tall. Or 40 feet long, that is. The height of the flagpole we don't know, but the flagpole has a shadow that is 50 feet long. Okay, so we need to do something here now. So the issue that I have right now is that we have 5 feet 4 inches. I need to pick either feet or inches. So I'm going to convert this to inches. So 5 feet, I'm going to take 5 and multiply by 12. So that'll give me inches, and then I have those extra 4 inches. Okay, so 5 multiplied by 12 is 60, add 4 is 64. So this is 64 over 40 equals x over 50. All I did was convert 5 feet 4 inches to solely inches. So 5 feet is 60 inches, and then I have those additional 4 inches. Okay, now I'm ready to use cross products. So I get 40x equals 320. Sorry, I mean 3,200. If I divide by 40, I get x equals 80. Okay, now what are the units? Well, if I look back, this was 64 inches, 40 feet, 50 feet. So this is going to be in inches. So this is 80 inches. Does that make sense? Well, the woman's height was 64 inches, and she had a 40-foot shadow. The flagpole has a longer shadow. It's 50 inches, or 50 feet, that is. Therefore, it should have a taller height. So the flagpole is 80 inches tall. But the question says, how tall is the flagpole to the nearest foot? So this means that I need to do some converting. So I'm going to do this over here. So I have 80 inches, and I want this converted to feet. 1 foot is 12 inches tall. Okay, so I have 80 multiplied by 1, which is just 80, and then I need to divide by 12. When I do that, I get 6.6 repeating. Rounded to the nearest foot is 7 feet tall. So the flagpole is about 7 feet tall. Okay, so it says, now suppose that a 58-inch child is standing next to the woman. How long is his shadow? So right now, take a minute, pause the video, and do this one on your own, please. You will probably need a calculator. Do not come back until you are finished. Okay, let's see how we did. I'm still comparing height to shadow. I know that the woman is 64 inches tall and her shadow is 40 feet. This doesn't really make sense, does it? I think I probably meant it to be 40 inches originally. But anyway, let's go with 40 feet because that's what I gave you. And then we have the child who's 58 inches and we want to know his shadow. So this is the woman. This is the child. And then I know that my tree is 7 feet tall, or 80 inches tall, and has a shadow that is 50 feet long. So I have 3 ratios here. I only really need 2. So I'm going to ignore this one. And I'm going to use this ratio to the left. I'm going to do my cross products. So I get 64x equals 2,320. I then have to divide by 64. and I get 36.25. Which means that the child's shadow is 36.25 feet long. Again, that doesn't make sense. I must have given you the wrong units. But hopefully we have the right idea. You could have used this proportion instead, and then your answer would have been a little bit different. If you did that one instead, your answer would have been 36.25 still. So it would have been the same. So hopefully that one went well for you. When you come to class tomorrow, I will be checking your notes as well as this example 4. I need to see, yes, they could be similar, no, they cannot be, and an explanation of why. Good luck.